Hello, welcome back to our channel. Today we are going to discuss about few problems from the previous MSET papers. That chapter name is the dual nature of radiation and matter. See, once you read this question, a beam of photons with an energy of how much? 10.5 electron volts strike a metal plate. Then what happens? Those are moving with maximum velocity 1.6 into 10 to the power of 6 meters per second. The work function of the metal we should find out. Clearly they have given mass of the electron is 9 into 10 power minus 31 kgs. Charge of the electron also they have mentioned 1.6 into 10 to the power of minus 19 coulombs. Look here, given data is energy they have given, maximum velocity they have given. We have to find out the work function. How to find out the work function here? See, look, in this first we are going to given data we should write it. Energy is in electron volts they have given 10.5 electron volts. V maximum is 1.6 into 10 to the power of 6 meters per second. They have given mass of the electron. From the Einstein's photoelectric equation, that energy is utilized to liberate the electrons, nothing but work function and maximum kinetic energy. But we want work function means instead of energy what we are writing? 10.5 electron volts. But here maximum kinetic energy, what is the formula? Half into mass into velocity square. So half into mass of the electron is the 9 into 10 to the power of minus 31 kgs, and charge of the electron is how much? 1.6 into 10 to the power of 6. Velocity square means we are taking square into electron volts. We are taking in terms of electron volts, divided by charge of the electron is how much? 1.6 into 10 to the power of minus 19. This is the half mv square formula. But here electron volt we should convert into in terms of electron volts means we are dividing with electron volt. Then phi equals to 10.5 electron volts. After simplification, what you are getting? This is the 7.2 electron volts. 7.2 electron volts. Just we have to do the subtraction. Then finally our answer is phi naught equals to 3.3 electron volts. So you should remember this is the formula. From this formula we can find out the work function. Then our next question is, it's a very easy answer. Look, the de Broglie wavelength of the electron in the first Bohr orbit of the hydrogen atom is. Bohr orbit of the hydrogen atom is. So for this what we are taking? We can take it. You know that de Broglie wavelength, what is the formula? V equals to mvr equals to nh by 2 pi. But directly we can use this formula. 2 pi r, circumference of this one is nothing but lambda. You know that v equals to n lambda. Lambda equals to v by n. Here lambda is nothing but what? It is having the circular motion. Circumference of this one, 2 pi r equals to v by n. Then after simplification what we are getting? 2 pi r equals to lambda. So which option is right in this? In this, second option is right. Here what they have given? Equal to the circumference of the first orbit. Circumference of the first orbit. Then come to third question. The question is, see, photons of energy 2.4 electron volts and wavelength lambda falls on a metal plate and release the electrons, nothing but photoelectric effect only. So with a maximum velocity v, by decreasing lambda by, here lambda is, second case lambda is decreased by 50%, then maximum wavelength of the photoelectrons becomes to 3v. The work function of the metal plate is, so same metal plate means same work function. It depends on the nature of the material. Same question, same formula we can use here. First we can go through the given data. Look here, see, lambda 1 equals to lambda 2 equals to 50% of this one means lambda by 2. V1 equals to v, V1 equals to V, V2 equals to 3 times of that one. So what is the formula here? E equals to phi naught plus Ke maximum. Instead of E, Hc by lambda. For our simplifications, you should remember that this is Hc by lambda, phi naught plus half mv square. Then second case, Hc by, instead of lambda 2, we are writing lambda by 2. phi naught is the same as usual, plus half into m into velocity is increased to how many times? 3 times. Then we have to take the ratio between these two. Ratio between these two. This one hc by lambda cancel. You are getting 1 by 2 equals to this one. Then we can go through the cross multiplication. So 2 times of this one and 1 time of this one. After equaling, we are getting that phi naught equals to 7 times of that kinetic energy. But in our problem, kinetic energy they have given 24 electron volts. 2.4 electron volts. So like that we can solve this type of problems. We can solve this type of problems. So our final answer, we are getting 2.4 electron volts, work function equals to 7 by 8 times of this one. Then come to our next question. See, that is the fourth question. Let V1 and V2 be the maximum velocities of the emitted electrons, and E1 is the 4 electron volts, E2 is the 2.5 electron volts. If the work function of the metal is how much? 2 electron volts, then the ratio of V1 and V2 is, same here also we are using Einstein's photoelectric equation. From this half mv square equals to what is the formula? E minus phi naught. Look here, half mv square equals to, means kinetic energy equals to E minus phi naught. E minus phi naught. This formula we are using. So LHS side we are taking half mv1 square equals to, they have given that energy is 4 electron volts minus phi naught. Same metal means don't change this one, this is same. Then second case, half mv2 square equals to 2.5 minus phi naught. Okay, then half m cancel, v1 square by v2 square equals to, instead of phi naught we can write it 2, they have given that. Then v1 by v2 equals to under root 4 minus 2 is the 2 and 2.5 minus 2 is the 0.5. After simplification, 20 by 4 is the under root 4 equals to 2:1. So like that we can able to find out the velocity ratio with the help of the Einstein's photoelectric equation. Then come to fifth question. These problems are very easy, limited formulas are there. See, when the energy of incident radiation is increased by how much? 20%. The kinetic energy of the photoelectrons emitted from a metal surface increased from 0.5 to 0.8. So then the work function of the metal, same formula we are using. Total energy, you know that it is utilized into two ways. One is the to liberate the electrons, nothing but work function. Another one is what? To give the maximum kinetic energy. Look here, this problem. Same, first one is how much? Energy. Energy equals to phi naught plus 0.5 electron volts. This is the kinetic energy, work function, energy. Second case, it is increased to how much time? 20%. So 20 by 100 of that initial energy. This side phi naught, same, this is the same metal, 0.8 electron volts. Then after simplification, E cancel. You can take LCM here. How much it is? 120. Denominator is the 100. So 100 by 120. LHS, I look here. 100 by 120 equals to how much? 5 by 6 is equals to, we are equaling to this expression. Then you can go through the cross multiplication. 5 pi naught plus 5 into 0.8 electron volts equals to this much. Then phi naught equals to 4 minus 3, 1 electron volt you are getting. It's very easy. You must remember that Einstein's photoelectric effect and work function depends on the nature of the metal, means even denominator and numerator same metal, means we are taking phi naught and phi naught. Then come to our sixth question. See, look here, sixth question. In a photoelectric effect experiment, if the frequency of light is doubled, the stopping potential will be. Here we have to find out the stopping potential. Stopping potential is represented by V naught. See, N is, look here, N is directly proportional to kinetic energy, is equals to, you can express in terms of electric potential, EV naught. Then N dash equals to 2V naught. More than that, double we should observe. Just you remember that. If you want explanation, you can go through this one. See, EV naught equals to energy minus work function. EV naught is the kinetic energy here. We can write in terms of EV naught also, stopping potential and charge of the electron. From this V naught equals to, we are sending this E is this side, it coming as a denominator. When nu is the increased to twice, so frequency is increased to twice. So instead of h nu, what we are writing, 2h nu by E minus phi naught. Then V0 dash equals to 2h E by, here minus pi naught by E means just I am taking 2 pi naught by E minus pi naught by E means once again we are getting the minus. So when we are taking 2 is the common inside, h nu by E minus 5 by 2E plus phi naught by E, like that you are getting. Then after that already you know that this is V naught. 2 V naught plus something means it is more than twice. That's why our expression V naught dash equal is greater than 2 times of that V naught. Then seventh one is, the seventh question is, this is theoretical question only. What they have given, look here. According to the photoelectric effect, the plot of kinetic energy of the emitted photoelectrons from a metal versus the frequency of the incident radiation gives a straight line whose slope is see is the same for all metals and independent of the incident intensity of radiation. You know clearly that what we know that, see, kinetic energy is directly proportional to frequency. It does not depend on the intensity of incident radiation. So first option is right. Then come to eighth question. This is also based on that Einstein's equation only. See, eighth question. A light of wavelength 310 nanometers is used. 300 nanometers is used in a photoelectric experiment. The metal electrode work function they have given, wavelength they have given, the stopping potential of the photoelectrons we should find out. They have given Hc equals to 1240 electron volts nanometers. Already I said that 12,400 angstroms. Instead of angstroms they have taken the nanometer. See, in this question it's very simple. While reading this question is like big like that. Work function is 2.5 electron volts. Hc is the 1240 electron volt nanometer. Lambda is the, all are in nanometers. Then kinetic energy, what is the formula? Hc by lambda minus phi naught. Substitute all values. See, 1240 by 310 nanometers cancel, minus 2.5. After simplification, volts, what is the stopping potential? 1.5 volts. Then come to ninth question. This question also very easy. A particle of charge q, mass m and energy E has de Broglie wavelength lambda. For a particle, charge now increased to 2 times, mass is also increased to 2 times, energy is also increased to 2 times. The de Broglie wavelength is, simply we can go through that. Lambda equals to h by under root 2me. So lambda 1 by lambda 2 equals to under root m2 by m1 into e2 by e1. So 2 times of m, 2 times of energy. After simplification, lambda by lambda 2 equals to 2, lambda 2 equals to lambda by 2, half of the wavelength of the initial. Then come to our next question. Here also this question is, see, the wavelength of a charged particle, mass they have given, charge they have given, kinetic energy they have given, Planck's constant they have given. We should find out the wavelength. Directly you can go this formula. Lambda equals to under root h by under root 2m into kinetic energy. Instead of kinetic energy, you should write it 3 into 10 to the power of 3. Why? They have given 3 kilo electron volts. Instead of electron, I have written 1.6 into 10 to the power of minus 19. As usual, this is 2 into mass of that one into 3 into 10 to the power of 3. Charge EV means in terms of joules, I multiplied with 1.6 into 10 to the power of minus 19. After simplification, you are getting that answer 0.23 angstroms. See, here 10 power minus 10, I have written as a angstroms. So, this is about the few problems from the dual nature of radiation and matter. Thank you everyone. Please follow my videos and subscribe the channel.